Hello everyone, it's Lucy here. Starting from today, I'll be uploading a weekly video focused on the topic of ether. Ether is a vast and intriguing subject, often considered fundamental to the underlying principles of modern scientific advancement and central to the concept of free energy technologies. The significance of understanding ether is immense, yet information about it is surprisingly limited. To address this, I'm going to explore it in a series of videos, aiming to cover the topic as thoroughly as possible. The term ether may sound familiar to many of you. It often emerges in an unusual context in the information we come across. On one side, mainstream science views the concept of ether skeptically. The well-known Michelson-Morley experiment, for instance, failed to prove its existence, leading many to label the ether theory as pseudoscience. On the flip side, ether frequently features in various genres like fantasy, science fiction, and other fantastical literature, representing a kind of elemental force in these narratives. A notable modern reference to ether is the cryptocurrency Ethereum. Its creator, Vitalik Buterin, renamed it Ether, showcasing the grand scale of his vision. But what exactly is ether? Ether is the ubiquitous substance in the universe, the most primitive element that forms our physical world, and the physical medium that supports the propagation of light. As early as in ancient Greek times, Aristotle hypothesized about the ether, and until the beginning of the 20th century, almost all physicists took it for granted. This is because both classical optics and Maxwell's theory of electromagnetic waves implicitly include the concept of the ether, which would be meaningless if there was no fundamental medium in the universe. For example, Maxwell believed that the ether is a fluid filling all space, and after he proposed the theory of electromagnetic waves, he suggested that the speed of light might depend on the speed of the ether. Maxwell was the foremost authority on physics at the time, so his hypothesis prompted physicists to conduct experiments to test it. However, the famous experiments conducted by American physicists Albert Michelson and Edward Morley failed. The most famous failed experiment in the history of science is based on the assumption that the ether is stationary in space and that the Earth travels through it. Therefore, it is assumed that the Earth, in the process of orbiting the Sun, must pass through the stationary ether, and because of the Earth's movement, there must be an etheric wind blowing through the Earth at all times. A beam of light emitted in the direction of the Earth's motion should travel faster than a beam emitted at right angles to the Earth. The phases of the two beams of light should be inconsistent, and interference fringes should appear. Albert A. Michelson's first experiment, conducted in 1881, did not show interference fringes, nor did a second, more complex experiment, conducted in 1887. This means that the two beams of light have the same speed and are not affected by the etheric wind. This experiment has been widely interpreted by modern mainstream physics as evidence of the non-existence of the ether, and it is the source of most people's current lack of knowledge about the ether. But at the time, after the failure of the Michelson-Morley experiment, no one suggested that the ether might not exist at all. This experiment only proved the non-existence of ether wind, that is, the ether is not like stationary air, and movement within the ether will not produce wind-like effects. In fact, starting from the Victorian era, the scientific community generally recognized the existence of ether. The reason is simple, as the British physicist Sir Oliver Lodge said, "If waves setting out from the sun exist in space 8 minutes before striking our eyes, there must be in space some medium in which they exist and which conveys them. Waves we cannot have, unless they be waves in something." Lodge said, "The ether is not an ethereal thing, but is treated as a substance with determinable physical properties." As for why the Michelson-Morley experiment did not capture the ether, Lord Lodge explained, "We have no means of getting hold of the ether mechanically, we cannot grip it or move it in the ordinary way, we can only get it electrically." Remember this sentence, it will be the key to solving the mystery. In fact, not only Sir Lodge, but physicist George Fitzgerald also offered his own explanation for this failed experiment. He said that the size of objects moving in the ether would shrink relatively. The Dutch physicist Lorentz and the French mathematician Henri Poincaré later developed this idea into a complete theory. This was later known as Lorentz's principle of relativity. He asserted that no experiment could detect the movement of an observer through the ether, because the observer would compress and stretch as the ether in which he was located compressed and stretched. Sound familiar? Did you think of anything? By the way, does Einstein's theory of relativity also mention a relationship between speed and physical size? The faster the speed, the shorter the size. This is the so-called shrinkage effect. Isn't this the content of special relativity? You heard it right. The principle of relativity was not invented by Einstein, it existed before him. In fact, it was Galileo who first proposed the theory of relativity. Galileo stated that the laws of physics remain unchanged in all frames of reference that are either at rest or in uniform motion. So, when we see the water in a cup staying still in a carriage moving at a constant speed, we shouldn't attribute this to the greatness of Einstein's theory of relativity, because Galileo was the first to propose the principle of relativity. However, Galileo's theory of relativity cannot explain the speed of light. According to Maxwell's equations, the speed of light is 300,000 kilometers per second, which appears to be constant. To explain this phenomenon, Lorentz's theory of relativity was developed, centered around the concept of ether. During this period, the scientific community realized that the ether was not an absolutely stationary medium independent of time and space, so it could not be detected using the Michelson-Morley experimental method, necessitating a more complex model. However, not long after that, an event occurred that drastically changed the physics world, effectively burying the concept of ether under the scientific edifice. This event was the birth of Einstein's theory of relativity. Einstein's special theory of relativity is based on the Lorentz transformation and is almost a direct adaptation of Lorentz's theory of relativity. The key difference is that Einstein proposed the principle that the speed of light remains constant. Note that Lorentz's speed of light is the relative speed in the ether. Since the observer is in the ether, changes in the speed of light cannot be measured. Einstein's speed of light refers to the absolute speed, that is, the speed of light in a vacuum is always 300,000 kilometers per second. In fact, in the scientific community, many believe that Einstein plagiarized the principles of relativity, including the famous mass-energy equation, E equals mc squared, which was not originally his, but was penned by Italian industrialist, physicist, and geologist Olinto di Pretto. As early as 1903, 2 years before Einstein published his special theory of relativity, di Pretto published this equation in his book The Ether Hypothesis in the Life of the Universe. Although Einstein did not refute the concept of ether when he proposed the special theory of relativity in 1905, he replaced it with the concept of field. In the general theory of relativity, Einstein directly introduced the concept of spacetime and incorporated the entire spacetime into the gravitational field. This is undoubtedly a form of self-deception, because any field is only the excitation of the underlying physical medium and cannot exist without it. Einstein's own views on ether have fluctuated over time. In his paper Sidelights on the Theory of Relativity, he wrote, "There is weighty arguments to be adduced in favor of the ether hypothesis. To deny the ether is ultimately to assume that empty space has no physical qualities whatever. The fundamental facts of mechanics do not harmonize with this view. According to the general theory of relativity, space is endowed with physical qualities. In this sense, therefore, there exists an ether. According to the general theory of relativity, space without ether is unthinkable." However, when addressing the quantum nature of light, Einstein cancelled out the ether as unnecessary by assuming that light traveled in quanta and therefore had particle-like properties and was not merely a wave that required some material to do the waving. This passage, quoted by the renowned science fiction author Isaac Asimov, is thus widely known. As a result, people tend to remember only Einstein's dismissal of the ether. A significant contribution to the ether debate seems to have come from an Italian, Professor Marco Todeschini, dean of the physics branch of the Titan Academy of Sciences. In March 1956, at the 25th International Congress of the American Physical Society, scientist Oppenheimer discussed the behavior of antiparticles and subatomic phenomena. These phenomena sharply contradicted Einstein's theory of relativity. Consequently, Dean Todeschini argued, in line with Galileo's viewpoint, that a return to classical physics is necessary. The conclusion that it is Galilei's relativity, and not Einstein's, which is found in the universe. Regarding the failed Michelson-Morley ether experiment, Professor Todeschini offered an explanation. A motionless ether exists in the whole universe. It exists, but in proximity of the Earth it moves jointly with it in its revolutionary, rotating, movement round the Sun. Todeschini hypothesized a fluid space with a constant density, as opposed to the weightless ether previously envisioned by physicists. Based on this theory, he demonstrated that the Sun is located at the center of a vast rotating space fluid field, divided into many concentric layers of constant thickness, with the rotational speed of each layer decreasing with distance. Todeschini's theory also suggests that the Earth is at the center of a similar, smaller rotating field, on the periphery of the larger solar rotating field. Todeschini conducted extensive tests to support his claims. Returning to Michelson's experiment, Todeschini pointed out that it was based on the assumption that the ether was stationary throughout the universe. However, I have demonstrated that our planet in its revolution movement drags with itself its surrounding medium of ether just as it carries along its atmospheric quilt, and this makes us certain that the Earth is in the center of an ether's planetary sphere. It is based on the assertions of Sir Oliver Lodge, Professor Todeschini, and many other scientists, who jointly pointed out a major scientific fallacy that has led to erroneous conclusions in contemporary physics. Professor Todeschini stated, "All these new experimental results refute the hypothesis of the constant speed of light, which has been the basis of physical theory since 1905, and convince us that this theory is not consistent with physical reality. The contraction of objects and the dilation of time that underpin Einstein's theory of pseudo-relativity simply do not occur in natural reality. In fact, they were hypothesized based on incorrect physical interpretations of astronomical aberrations and Michelson's experiment." But it was during this period, as the discourse power of mainstream physics continued to shift, that ether was gradually forgotten and abandoned as a seemingly outdated physical concept. However, with further developments in physics, it has become clear that the vacuum of the universe is not an empty space. Instead, it is a stage for intense physical processes. Scientists have observed that the vacuum is full of energy fluctuations, with pairs of virtual particles appearing and disappearing, and interactions between the vacuum, particles, and other phenomena. This led to the introduction of terms such as physical vacuum and vacuum structure. These terms are quite perplexing. They continue to describe it as a vacuum, while also acknowledging the presence of virtual particles and structures. I believe that most people don't understand what this means. Thus, some say that the universe was created out of nothing, as if energy can literally emerge from nothingness and then disappear again. In fact, all of these concepts, including spacetime, gravitational fields, the sea of energy, and vacuum structure, all point to the idea that what we call a vacuum is actually a physical medium, that is, the ether. Therefore, although the Michelson-Morley experiment failed, it doesn't mean that the ether doesn't exist, but rather that the method of detection was incorrect. In various subsequent physical theories, whether it be relativity, quantum mechanics, or the standard particle model, the existence of ether has been reaffirmed repeatedly. Theoretical physics cannot disregard it, so it is often reluctantly referred to as a vacuum. Indeed, British quantum physicist Paul Dirac once said, "The etherless basis of physical theory may have reached the end of its capabilities, and we see in the ether a new hope for the future." He used mathematical methods to demonstrate the actual existence of ether at the University of Cambridge. At this point, we have only just begun to address the issue of ether, because the above debate about its existence mainly exists in theoretical proof. But if that's all there is to it, the ether theory, like the theory of relativity and even string theory, remains just a hypothesis. Do you remember Sir Lodge's earlier words? We have no way of mechanically capturing the ether, we can only detect it through electricity. This statement will continue to prove its validity in the future. The person who truly harnessed ether through electrical means was the legendary Nikola Tesla.